All right. So, hello and welcome. Welcome to my stream. We will be doing a code editor in Zig. If you don't know about Zig, that is a beautiful language, a beta C, and we will do some coding in it today. So first of all, I would like to go through some changes since the last time. We have quite a few. I didn't add any new functionality, but I refactored and did renaming. So first thing is that we have a front end instead of back end in UI. That is kind of, it can be interpreted in two different ways, because UI is our front end to the backend, the server which is going to do all the heavy work, and UI is kind of what we see on the screen right now. And UI can have different like terminals, maybe Electron application, maybe GTK or something else, and before we call them backends, because in relationship to UI they are backends. But in the grand scheme of things, it is actually a front end, so we will call it that. Then I renamed these functions. Previously I had some name clashes, name collisions because of them, and I just decided to prefix them with CC, which stands for console code. And I think it will be fine this way. And another change is that now this function refresh, which flushes the buffer with the buffered content, we have it not to call it inside an implementation of a front end. It should be only called in this UI struct, which is a high-level abstraction around any front end. The idea is that we have a front end like this one, UI VT100. For those of you who don't know, VT100 is a model of terminal, like hardware terminal, very old one, from 90, like 70, 80, 60, somewhere around that time. And we will implement it as a part of this whole process, but later we can have different front ends. All right, so today I would like to implement our client-server communication. I want to do it for a number of things. First, we already have some structure, we have already some functionality. Yeah, let's actually run what we have already to demonstrate it. So we can move our cursor. Yeah, we can move it. And we can also insert some characters. For now, we don't care that they're inserted not at the place where the cursor is. And the cursor is moved to the first line, but is just a little bit of more work to do. And with that, we kind of have the general idea of what calls what should manage what. And with that, we can implement our client-server architecture. I believe that we should implement it early, because later on in the development we might have some problems because we too tightly coupled some things which should not be coupled. And although networking early is generally considered a very bad idea, like in microservices architecture, everyone in web development, right? There is microservices where everyone speaks with everyone, and it is not very, maybe not very, but it is kind of hard to manage it, and if you start with it from the beginning, it is kind of frowned upon. But we have a very good situation, because our server and client lives on the same machine, and so we should be with minimal troubles. Well, I hope at least with minimal troubles. I cannot predict it. Probably we will have troubles, maybe even real troubles. Okay, so for the starts, maybe let's take a look some more talking. So Ravi387 says, can you overview me on Zeek programming a little bit? Okay, sure. Zeek is a C-like language. It just tries to be a better C. There is Zen of Zeek. Let's Zeek Zen. So these are the values of Zeek, and maybe some of the most prominent ones are together we serve the users. It's kind of not about the language, but still it's a very friendly community, I would say. Yeah, I think if you would like to learn it, you will love the community. Memory, very careful memory edge cases, very careful edge cases. Communicate intent precisely, also very explicitness over implicitness. You maybe heard that in Python. I think this is kind of same. And just to give you a general feel, we have a lot of errors. Errors are very explicit. So here, for example, this can return an error, and we want to catch it, and we want to switch on it. And if this is file, for example, not supplied, we do this scene. If it is other scene, we do another scene. Right? So it's very explicit with errors. And another feature is that this is allocator code. Like very cool stuff that if you do not pass an allocator to a function, it does not do any heap allocations. I think very beautiful. And yes, it has type inference. For example, here you can see that I don't use any types. I just pass it in, and it knows the exact type of it. So maybe we can also see some code. I would like to first implement a proof of concept of the process of the inter-process communication, right? And first, let's look at the wiki IPC. I'll give you a brief introduction to this topic. So it's basically a lot of ways how to do inter-process communication. We will have client server, and they need to communicate. My main focus was on Unix domain socket and on pipes, anonymous pipes. All other options seemed less viable. These two are very great, and we will go with anonymous pipes. Compared to socket, they're much more low level, and they will be easier to implement at the beginning. But since we will do modular design, we will be able to abstract everything, and we will be able to implement socket as well. This socket stuff will also allow to do a very easy switch on the networking. For example, you can use TCP, you have some server around, and you from your personal computer can connect to the dedicated server, but it's not a very common use case, so we will just go with anonymous pipes as they're more low level and just a stream of bytes basically for us. Okay, Ravi asks, can I call Zeek in Python? I'm interested. Zeek in Python. If you mean, can you do some libraries? Python has this feature that you can do FFI with C libraries, and Zeek has very good support for C ABI, so I'm pretty sure you can. I don't know how to do it exactly, but I think even if you don't find it yourself, you can ask around. People will help you with that. No problem, I think. Okay, so we have some stuff here. Some proof of concepts on the sockets, and we will try to do the simple thing where we just try to create a server, try to create a client, and make them communicate with each other. So let's begin not even with our main file, but with we'll just create tests, and maybe not tests, right? Maybe we can create a new directory. Let's call it POC, proof of concept, and create a file here, POC, and we call it IPC underscore pipes. That's it. Okay, let's put some boilerplate here. Pub and main void, and let's do print hello world, just to make sure that everything is good. Hello world. Okay, so now we'll use seek run POC IPC, and yeah, perfect. So Ravi asks Zig C Python. Can I call Zig in Python? So I'm not sure what you mean by that. Maybe you can ask a little bit more explicit question about the Python. Here I'm doing a code editor, as you can see from the title, and we will do a code editor. Basically, this is my main project. So let's, we should first create a pipe, or I mean even two pipes. We will need one pair for client server and one pair for server client communication. I think they are in OS or in process. So let's try to find it here. Pipe. Yeah, sure. We have it here. So we'll need OS, I think, a lot. Let's just add it with just to save a bit of typing, and maybe relay an intent that we would like to use it a lot. And OS pipe, and we get 2 FDT, and 0 is going to be for reading. Yes, I suppose so. Yeah. Okay, so now we will create var, I believe. Yeah, we will do it maybe even a little more explicit. Client, let's say it like so, client writes server. Oh, maybe not yet. Let's just create FDs. Try os.pipes pipe2. It also accepts flags. Okay. We might need flags for non-blocking I/O, I guess. But since it is a proof of concept, we can just do it like so. Doesn't accept any arguments, and we will get our 2 FDs. So now we will do a fork, right? Let me quickly look up the fork docs. Create a child process. No examples, maybe in POSIX manual. Yeah, so 0 is for the child, and if it is not 0, it is a parent. So basically a fork is something that will allow us to share this code with 2 processes simultaneously. This is a new thing for me, so I'm trying to do my best, but I think this is a moment where I will make several mistakes. So hopefully we will be able to catch them early and not spend too much time on it. Okay, so we will need a PID of the child process. We need also fork, whereas fork, yeah, it is also in OS. Very convenient. os.fork. and it does not accept any arguments. Beautiful. And we have our branch for the child, and we have our branch for the server for the parent. Okay, so client and server, who is a child and who is a parent? Well, obviously, server should be a parent. Okay, let's do it like so. We will do a communication. Let's also leave some comments about it. Communication from client, maybe with capital letter, from client to server. Yeah, oops, I shouldn't save it, because on save I have zig fmt automatically. Okay, now client should yeah, let's okay okay, I I understood what I wanted to do. We need some kind of read and write for the client to read and for the server no, for the client to write and server to read, right? Let's call it read and it should be 0, and write and should be 1. Okay, so a common practice, since we are doing a fork and this is going to be executed in both child and parent, these both descriptors will be copied to both of them, and we want only one of them to be used. So yeah, I think this is reading is here, writing is here, because 0 is like standard input, std in, which is 1, where we want to write stuff, and 1 is like standard output, like so. Okay. This is a child, a client, so we want to close the read end. Okay, that close. And on the parent, we want to close the write end. Okay. And let's try to compile that. IO does not support field access. Okay, so it means that our PID, we cannot close a PID directly. Let's see maybe an example how to close having just a PID. Not here, maybe I also don't see it here. Okay, maybe our lucky third example. Oh, it's a socket. I guess it is Unix domain socket. Okay, maybe here. Okay, report and exit. Close. There is a close function which takes PID, and yeah, right end is 1. Yeah, we have it as 1. No, we have it as 0. Okay, maybe maybe like so. Read and write end. Okay, read from 0, write to 1. Okay, we can live with that. So maybe we should find a close function which is going to work with PIDs. Maybe there is a close. Oh, how convenient. Yeah, beautiful. So we shouldn't write it like that. We should like that. And repeat same here. So here we want to write, so we close the read end, and here we want to read, so we close the write end. Yeah, also let's add a comment. Client writes and server reads. Okay, so far seems fine. Okay, let's now write some stuff to it. How would you we probably need a writer interface or something like that. FDT. Well, it is a file descriptor. Yeah, it is a file descriptor, right? Can we read? Okay, we can read a file descriptor. Is there a reader interface for file descriptor? I believe we can do it like maybe OS file. Oh, file.zip. Oh, I also remember there is this get std out somewhere. We should find it, and it has a nice conversion between a file and just a raw file descriptor. We should just find where it is. Okay, let me go to the root std lib std and get std out. Ah, it is in IO. Yep. So handle, capable IO mode, intended IO mode. So we can do that, I think, or maybe there is a function which just wraps, which takes a file descriptor and wraps it in a file. Okay, maybe it is in the file itself, file.zip. stdy file. Or maybe we can just create it, right? Does it have init? Some kind of init? No. Yeah, I don't think I see anything useful here. I guess we can just create it, right? We can just read these comments and probably just default mode, like in the get std out or std in, because what we do is very similar to these things. Okay, I handle, then capable IO mode, blocking, intended IO mode, default mode. And what is the default mode? Do we have it? Yeah. If async. Okay, we just need to put block in here and block in here. All right. Let's call it var read stream, and it is going to be os or io.file. I think it is io.file, right? File or fs.file. Yeah, fs.file, sure. std fs.file. Yeah, and we just created. Handle is going to be right end, and both modes are going to be blocking. Capable IO mode, blocking, and we maybe it is a conversion. I'm not sure if this is going to be converted, but we will see. And intended IO mode is blocking too. Okay, I'm going to compile. Unused local variable. Read stream. Okay. Maybe we can, yeah, write stream, sure. Right here. Maybe we can as well write something to it. Write stream, writer, and write all hello and try, of course. Okay, so everything seems fine. So now we will have our server. We should do probably something similar. This is going to be a read stream. We'll use a read and. We also will use a read stream here and here reader. And we will use a buffer, right? Buff. It will be. We need how many bytes? 1, 2, 3, 4, 5, 6. And just in case 7, because I'm not sure if there is end of file. Probably not, right? So we need only 6 for that. U8, of course. And we go with read. We I don't remember exactly. Let me see a reader interface. Docs, read all, self, and buffer. Oh, sure. Buff, yeah, is this right? We need a slice, yeah, let's just pass a slice, like so, yeah. Okay, and yeah, we also want to print it. Debug and print read from buff. And we pass a buffer. Let's go. Oh, okay, it returns the number of bytes read. Yeah, by the way, is it going to, like, is this write going to be atomic? I mean, do we need to call this read only a single time? I think there is some documentation about atomic and non-atomic operation. Atomic atom. Okay, maybe we can find another manual. Like pipe 7, yeah? 7 pipe. Atomic. Okay, POSIX.1 says that writes of less than pipe buff bytes must be atomic. Okay, that will help us a lot. And what is the pipe buff? Okay, here it says POSIX requires pipe buff to be at least 512 bytes, and on Linux it is 4 kilobytes. Okay, so 512 bytes. It should be pretty large for our purposes. We will need to pass some JSON because we will be using JSON-RPC. I believe it is the easiest choice. Okay, so okay, I think we are good. Let's let's still ignore this expression. And okay, we also we read here, and we probably don't need to ignore it here because it's void. And we want to make sure that we have read all 6 bytes. Yeah, const read bytes. And we will go with buff and only to up to read bytes +1. No, just read bytes because we're counting from 0. Alright. Yeah, sure, we got our proof of concept. Okay, so I think there is also a little moment with our program, because my understanding is that when we call fork, we have a child, which is an individual process which is not somehow connected to our program, but we still run the server program, and we probably don't want that, because we want how do I say it? We want our UI to be the first program, like we want our UI to run continuously. Let me say it like this. I believe that our terminal, we will run the program in the terminal, and there is a notion of controlling terminal, and our server, if we make it a parent, it will be in the controlling terminal, and we probably do not want that. So we will have to reverse. So in the child is going to be the server in our case. I really hope there are no hidden stones like with Linux system. So probably we'll be fine. Let's just hope that we'll be fine and fix all the problems as they arrive. Okay, so we'll commit our proof of concept. Proof of concept on pipes IPC. Yeah, let's use full words. Inter-process communication. Okay, so I'm pretty glad with what we have here. Let's go to fn main. So let's now start modifying our program. Okay. So all this code, no, not all this code. So here we read the file that we supply as an argument on the command line. Here we create some stuff which is partially on the client, partially on the server. And then we start listening for events. In this case, it is just reading keys. Okay, so it is mixed. I thought we'll have an easier situation that everything is a client or everything is a server. But okay, we can manage that. Yeah. So we will need two set of pipes because we won't have like a strict server-client communication. It will be more like a peer-to-peer communication. For example, a client will be able to send some key presses to the server, and the server will be able to notify the client that maybe file changed and client reloads the content automatically. Okay, let's create our first set of pipes, and we will be explicit here. Client reads, server writes. Okay, os.pipes, and as one, server reads, client writes, os.pipes. All right. So then we should maybe give a name to every end of a pipe for better clarity. So read is 0, okay? So client reads is this one, 0. Then client writes is this one at the index of 1, correct? Now server reads, so here at index of 0, and final one, server writes here at the index of 1. Okay, we have our pipes, our ends. So now we will do a fork. Const child PID fork, yeah, os.fork. Right. So now the child is actually going to be a server because we need it to be forked on the backend, while the terminal we are in is going to still be running, so we are able to interact with it. I think it's called a controlling terminal of a session leader in Linux terms, but I'm not sure I fully understand it all, but we will figure out as we go. So now we have our branches. If child PID equals 1, which means it is a child, and else parent. And let's also be explicit, server and a client. So okay, here we will have to put our server code, mainly initialization, and here client code. So let's start right now. Yeah, sure. First we will have to close the ends properly. Okay, and in chat, Matu, please tell me how do I read your nickname properly. What is the use case for client server? And there is a link to NeoVim remote. Matuba, yeah, thank you. Let's open that link. Would be useful to make graphics of how it's supposed to work. Yeah, I believe the graphics I'm planning to do it because I'm not doing it right now because I'm not yet have a fully fledged design of a system, but I definitely plan to do it in the nearest future. As soon as I do this piece of interaction between client server, kind of understand what goes where, I will make an graphics. Yeah, thank you for reminding about it. Okay, so what do they say? Okay, typical use cases. Let's take a look at typical use cases. Open files from within terminal without starting a nested NeoVim process. Well, it doesn't seem like a very general use case to me. Okay, let's continue. Open files always in the same NeoVim process, no matter which terminal you are in. Well, that is actually, that has some drawbacks as well, because once the server crashes, all the clients are crashed. For example, about this foot, in the previous stream, I got some links. I have saved them, yeah, here. This is a foot terminal, and it also uses, it is not a program, it is like a terminal itself. It also uses client-server architecture, and here they, maybe server daemon mode. Yeah, here they say that there is a very major drawback that if the server crashes, all the clients crash with it as well. Somewhere here it is, but in our case we are kind of fine with it, right? Because we don't try to make a single server and all the clients connect to it. We can just create one server per client, and only if the user wants to use this architecture where they have several windows in different places and all connected to the same server, we of course allow that. Use NVR as a Git editor, use NVR in plugins. Yeah, this is kind of somewhat true, because when you have a client-server communication, you kind of have interface already established, right? We will use JSON-RPC, and we kind of already have an interface for all these things. Git merge tool, scripting. Yeah, maybe I should also show a bit of Cocoon. Yeah, Let's take a look, a short sideways. Yeah, I don't know, Cocoon, and there is this guy or girl, Alex Serbo, who did Cocoon CR Crystal, and it's basically a very scripting thing that you have a Cocoon editor. This is Cocoon editor I use. You have a Cocoon editor in one window, and you have this little program in the other window, and you just manipulate your Cocoon editor with it. It's very beautiful. I like this idea. We'll be able to implement it as well as a third-party library. I think it's really cool. I didn't use it, but I really like the idea. Veliga says, hi, hello. Why do you want client server? For the same reason Cocoon has it? Yeah, I just answered it. But it still has some benefits. I really like the idea that we can have different front ends. This is main drive, main drive and force for it, right? Here we have our UIVT 100, and if you want to make a different front end, more than 50% of the code will be shared with it. So we might as well make a client-server architecture so we can have different front ends. Yeah, if I'm really lucky, I will have most popular most popular code editor for the Z programming language, and everyone will do their third-party libraries, client third-party front ends. Yeah, and we will use all the server code will be shared, and it will be very yummy, very yummy. Okay, so we are in the server part. We should close client reads, right? We should close both client things, right? I think this is right. We should close this one, and we should close this one, because we don't want any access to descriptors of the client in the server, and same wise in the client. Okay, so let's put some code where it belongs. So we can have this content we can have this content reading. It is when we supply an argument as a file, we read its content, and on base of that we create a text buffer which is going to keep our text in the memory. So it goes to the server, but in the future we might implement it as an event to the server from the client. To make a better architecture that server never does anything by itself. It only accepts requests from the client and acts based on that. But for now, we can be content with that. Okay, like so. Okay, and Veligo says, what do you think about the benefits of JSON-RPC based server client architecture that you're doing over having UI and a backend in the same memory space? Other than remote control, of course. I'm not sure I understand the part about same memory space. I think JSON-RPC is just like a form, right? A form of how you process different things. We can use same memory space. For example, when I did a short review, Wiki IPC, on Wiki there is a memory queue, if I'm not mistaken. Is it? Yeah, message queue, and as I understand it uses shared memory. Yeah, shared memory explicitly, shared memory. So this is a transport. I would call this a transport, and JSON-RPC I would call an application level protocol. So we can use any transport with JSON-RPC is my understanding. Okay, Valigo adds same memory space is when UI just uses the backend as a library, like just import it. Okay, so UI imports a server and uses it. Yeah, I believe this is a good idea. I really didn't think about it much. I was very sold on the idea of client server and Cocoon does it, but I think I just plainly missed this opportunity. Well, that is interesting. Yes. So do I just throw away all my design and beautiful infographics I was going to create because we can just import it? Yeah, it was too much in the sky or in the clouds. Okay. So for now, I think we will finish what we do now. We will see how it goes, and if it proves to be too hard to manage, I believe we can relatively easily switch to the import mode. Yeah, I think it could be done with import too. Maybe I should have a better vision of why we need a separate client and server. Yeah, I think I should do some maybe to-do list. Yeah, maybe we can create a to-do list right here. to-do.org, sure. We should do, yeah, draw graphics on the architecture and make better reasons why to even use client-server architecture. Yeah. And Matuba says pro and cons list with, yeah, with use cases, definitely that. So we have a better understanding of what we are trying to achieve. Okay, for now let's continue moving our code. So this is our front end and we want it to be on the client. Sure. This is a client thing too. Display window is a server thing, but it requires a UI, which is not good. It should not require a UI. We will deal with it in a minute. Okay, so now we do it like so. Event is a client and display window is a server, correct? Yes, correct. And this is on the client. Okay, so we said that this is on the client, this is on the server. Let's actually make it true. UI, we don't need to have a UI here. And yeah, maybe if we are going to use JSON-RPC, maybe we can just sketch out a library for that, like a smallish backend with basic functionality. Or maybe we can just send one to draw and be happy that we have drawn something. That could be good too. Yeah. So let's first make sure that we don't pass any additional arguments which should not be there. UI. So this call to render, what it should do is that it should actually make a message with these parameters, and it should send it to the client, so the client draws these things. Is this correct? I think so. Yeah, since we have client and server, maybe we should have also a kind of hub for communication, separate for client and separate for server. So client is going to have a UI and a server. Server is going to have buffers, right? Text buffers. We'll have many of them. Yeah, maybe just like so. I plan to do how to say limited? Yeah, limited array list, because I really don't like the idea of infinitely growing array list. It can cause, I believe, large amounts of troubles. Display windows, std array list. Yeah, sure, this is pointer to the text buffer and a pointer to display window. Okay, and we also want to have some ways of communicating. Okay, so this window is going to need to render this stuff, and it needs some kind of way to send, to tell the, it should tell the server, please send this thing to the client. Okay, so how do we even do it? I think server should know about its client and the client should know about its server. It sounds reasonable since they will be consistent. At least in our current implementation. But at the same time, we can't really put pointers here in the memory because it is not allowed in client-server architecture. And this is one point where we feel a bit underpowered because we didn't use a plain import. Okay, Cyberpawn says atstite. I thought this is Ruse, but teal about Zik. Yeah, teal is some kind of abbreviation. Let me find that. Teal abbrev. Okay, internet slang. I hope it's safe to work. Content, please. Okay, it doesn't say. Today I learned. Okay, online slang. Yeah, cool. Yeah, that is Zik. By the way, do you know about Zik, Cyberpawn? Okay, server needs probably PID, right? We can... oh no, we have all the right ends for the clients. Is that correct? I believe so. So yeah, we can have just pairs. A client can be represented as a pair of PIDs. Yeah? Yeah, let's do that. Const Cyberpawn says nope, just learned about it. Yeah, I think you will like it. At least I do. It's like a really cool language, beta C, in contrast to languages like Rust and NIM. I think they're more like beta C++, yeah? And Zik is like more on the bit lower side of the stack, beta C. So maybe you want to have that tool in your inventory too. Yeah, maybe you can look at it. Okay, client FDs, I guess. Client FDs is an array of OS FD type. Yeah. And we will have clients or client FDs. Maybe just clients. Naming for me, naming is one of the most of the hardest problems. Clients, okay. let's just say clients, and we will have some interface to interact with that client. Std array list of client FDs. And FDs is file descriptors from the pipe, right? Client pipe FDs. Let's be more explicit. Client pipe FDs. Yeah, Matuba says you can just put a to-do better name behind and use a LSP to rename. Yeah, LSP is for language server protocol. Unfortunately, LSP does not always work perfectly, and sometimes I have a good name from the start. From here, I will choose to just do it like so. But it's also a good idea. I often do it when I'm maybe not often. I don't stream like so long, so I did it once. At least once I already used this advice. And we need a server pipe FDs, which is going to be like so too. So a client is going to have just a single pair, and the server can have multiple pairs of client pipe FDs. Yeah, sure. Maybe we shouldn't be too explicit, not invent something beforehand. Okay, so that is one thing. Now a client has a UI, and it can read from the server, right? So we will have some function to like accept. Yeah, accept. Yeah, I will use this advice here. Better name. Accept. We will do a read from the server. Right, we already have the pipe FDs, so maybe we don't really need to do anything. Okay, and now we get our. Let's also name them here. I very like explicit names. I do not like the C style of short names, and you have to guess the meaning. And if sometimes I'm not proficient enough in the domain, and I spend a lot of time trying to understand what this abbreviation means. Okay, read end, where we read server reads, right? Server reads. I think we need another one. Okay, and it will be server. Maybe not even here, right? Maybe here. But at the same time, we have this here, so we should probably keep the same interface. Maybe not the same interface, but you understand here. So read is conventionally 0, and write is conventionally 1. Yeah. Okay, so when we accept, we want to read something from the server. Yeah, maybe we can also create a file. Yeah, let's create it here. Read stream. It will be var and std.fs file. It will have handle, read end handle, and it will have where I had it, yeah, this one. Capable intended error mode blocking. For now we don't care about non-blocking, but I'm sure we will need to add it later. And we create our buffer, I believe. Buff, which is going to be, let's just create maybe 10 bytes, right? And we'll read from this stream. We'll say bytes read and try to read stream. dot reader dot read into our buffer, and we do this little trick with 0 dot dot to say that it is a slice. There is also an option to make it like so. Say we pass a pointer, but as I understand, the more idiomatic Zeek is going to be like this, because we can also, I believe, say that we only want to read like up to 5, right? Like so. Okay, now since we have read something, yeah, we will need to accept all this text. Here in the display window, this is our render function. We pass 3 arguments: slice, this one, and this one, right? And we will need to have a large enough buffer to read it all. Okay, maybe we can do something about that. So what options do we have? We can just create a large buffer, like 4 kilobytes, right? Like here, and then 4 kilobytes, and read it in here. Maybe Zeek has some convenience function for us. Yeah, read all. It will. Yeah, it will just read several times to the same buffer, because the read call does not can return not everything that can be available for reading. Then the array list, we probably do not want that. Yeah. Oh, I have another idea. Because on the client we have this UI, and UI has a buffered read. Yeah. Let's for those of you who are new to this code base, in this UI VT100, it is a front-end implementation for the terminal. Our terminal front end, and we use this magic with types to do a buffered write into the terminal. For example, I will not be able to run right now because it's broken. We are just changing it now, but here when we write something to the screen, we should explicitly say, okay, we have written everything we want to write, please show it, flush the buffer. We use buffered writing. So here on the client side, we can have like 4 kilobytes. I believe this is okay. And we can just write this amount of bytes to the buffer, to the output buffer. And since 4 kilobytes is what we have, I mean, 4 kilobytes is also the size of our buffered output. Maybe it makes sense to do it of the same size. Okay, I like this idea that we receive, then we straight write, and we can receive more if you want to. Let me just take a look at the implementation of read all function. So index is not buffer_len, it will read more. So it is pretty simple, right? We want to use read all function, and we will still call it in a loop, I suppose. Or yeah, maybe it also makes sense to somehow connect. So here we have a reader, right? We read, and we want to straight write it to another buffer. Can we somehow connect these two streams? Yeah, I'm sure it's possible, but I don't know how to implement it exactly. Yeah, for now we will do it in a dumb way, very simple way, but I will definitely look up if it is possible to connect to ends of a stream and transparently write there. So for now we will do without any loops or anything. we'll just do a single one, but this will fail because if you have more than 4 kilobytes of information to receive, we will not receive all of it. But let's just do it the simpler way first. And okay, except, yeah, we still need self because we will need a reference to UI, right? Okay. Client. We go with self.client, no, self.ui dot, and what is the original call here? Render, and we need slice first number. Okay, so we need a little bit of more arguments than just simple. Yeah, I thought maybe we can just get this slice and send it straight to the end, but we need these characters as well. So are we going to encode it somehow? Because currently we are lazy to implement a JSON communication. Like maybe let's make it a bit bigger because I will use it for examples. Maybe like so, text, and then like so. Yeah, no, maybe like this pipe thing, and we pass 1 and second number. Yeah. Yeah, okay, let's do that formatting. It's very simple. We will get away from it as soon as possible. But for now, we will use it because it's simple, and we not have pipes in the source file? Okay, let me try to look once again. Oh no, we have this character. Yeah, we need a more rare character. What is like the rarest character, but still an ASCII symbol? Maybe. I think Zig uses pretty. Oh, maybe a tilde, huh? Like so. Do we have tilde somewhere? Yes, we have it. Okay, we'll just not use this text. Okay, we'll use a pipe because it is better pleasing for the eyes, and we'll use pipe. So okay, when we have these bytes read, we will use a split iterator from the mem.zig. Split iterator, yeah. It will just split on a single symbol or on a array of symbols as a string, and it will pass us all the necessary things so we can render them. Okay. Var it split, maybe pipe it, but no, we already use pipe as a communication. If we will use pipe denoting these characters here, we will, I think, get confused pretty easily. Okay, we have our buff, and we say that from 0 to the bytes read, because we don't want to read some garbage after the amount of bytes that we have actually read. And we want to use std mem split. Yeah, and we want to use our pipe character as delimiter, right? Okay, while split it next. So if we have some string here, we say that we definitely know that we will receive 3. So maybe we shouldn't even write this while loop. As we usually do with iterators, we'll say const slice equals split it dot next, and we use this little trick to say that if we don't get anything, just raise an exception and tell us. First line number is split it dot next, and text buffer max line number is split it dot next. So we shouldn't have anything else here, and we can use it like so. Okay, so we wrote some code for the client to receive some text from the server and to display it. Right, let's write a server code to do better name, because we do it in a very simplistic way. Send text. Yeah, good enough. Self pointer to the server. Okay, so we will have a single text buffer, I believe, and a single display window and a single client. So let's use it like so. Client is clients like so, items, because it is an array list. We should use items to refer to the slice. Then text buffer. Text buffers dot items dot 0, and there is also a bit tricky situation, because text buffers is every text buffer that we have, and display windows is also in every display window that we have. But at the same time, we want to refer to the display window when we send from the text buffer. This is why in the text buffer here we also have display windows, because one text buffer can be displayed in several display windows. Okay, yeah, and our client is currently kind of alone without any belonging to any text buffers, display windows. Yeah, we will fix it when we have to fix it. For now, we will just use whatever we have already established. We should be concentrated on the topic of just sending stuff. Okay, here we'll have to just display window, right? We want to create a variable. Display window, like so. Yeah. So now, since I think this should be vars, because we'll do some sending and it will mutate the internal state. Alright, so now client, text buffer, and display window. So now, display window, it should not try to call the UI thingy. It should do just that, and it should encode it and return a string. Yeah. So yeah, by the way, let's remove UI from here, and in here, UI from here. Beautiful. So where was I? Somewhere in the UI, and where's UI? Const UI. Oh no, we were in display window, right here. Yep. Now we need just to encode it with this format, and it should suffice for our implementation. Okay, let's say that we will return a slice, and we will create a temporary variable here. We'll call it text. I don't know, I'm really bad with names today, so I will just put everywhere to do better name. It will be std array list of bytes, and we initialize it. Do we have an allocator here somewhere? Rows, calls, text buffer. Can we use the allocator from the text buffer? Yeah, it has an allocator. Let's use an allocator from the text buffer. So we go with self text buffer.allie for the allocator. Okay, now we go with text dot append. Is this correct? Append slice. Yeah, we can just use that. And does append return anything? Let's have a quick look. Append. No, it returns void, so we shouldn't care about the not used return value. So now we write our... Yeah, I was worried that it took anything that we cannot pass. So here we can pass either char or string. We chose to pass a char, why not? Then append. Now we want this first line number, which... Okay, so I have just found a bug, I think. Oh, no, we still use it here. So no bugs, everything fine. So here we want to stringify it, make it a string, and append it. Okay, so how do I make number a string? Maybe I should use a writer interface. Okay, let's not refactor anything and just use it for this one case, and a further case we will need it. Maybe I should have done it from the very beginning with this writer interface, because otherwise we will have to use this append and print with writer interface in the same place. And I saw this to-owned slice. So I will need to read the docs actually for this function, but I saw that in the return position this is the function that is used. The caller owns the returned memory. Array list becomes empty. I think this is what we want, right? And maybe we also call the init. And Veligo says to own slice sounds almost the something from Rust. Yeah, I also have these rusty feelings with this kind of as, and when you do like this helper functions, very rusty. When are you going to add tests, says Matuba. I think tests will come a bit later, because for now we're just fleshing out implementation, but for some parts like test, yeah, for example for keys we already have some tests, so I'm trying to add them a bit opportunistically or when it makes sense, but I'm more of implementation first, then tests. Because we are in a very heavy state of design, I believe it is hard for now to do any implementation, any tests, because tests is also some code that we will have to support, maintain, and it's just another headache. Maybe we already have enough with client-server architecture. I will still rethink my decisions about client-server architecture. Maybe I just should import it instead. Okay, but we will leave it for later. I will do some work with infographics and stuff. Okay, render works. Display window can now render, and it will return a properly encoded string. Yeah. Okay, let's go to our server. Yeah, send text. Here we want to say that we have our message to the client, and try display window.render. I believe it does not accept any arguments except for display window itself, and we want to send it to the client. Okay, so it is a message, and we want just to use our client. Here we have just a single client. We want to say client dot. No. We cannot use this descriptors. We should use our own descriptors. So maybe it is a bit confusing when I think of it, that we have clients here, but it is actually for our server. Okay, we need our right end. Let's not focus on these little things. Maybe we can flesh out them a bit later. Client 1, this is our right, and we say writer on it. No, we should make a file, right? Yeah, we should make a stream, var write stream, maybe out stream, write stream. Yeah, I think I know what we should do here. Beautiful. std fs file and handle client, and we say 1 because we want the right end, and everything else we'll just copy. Okay, we have our write stream, so now we can just use it to create the write and say write all message. So looks fine. Send text and accept. And accept, I believe it will block on this line, read all. So we will block until we read everything we have. Okay, let's take a look at how we do things here. Text buffer, try display window render. Alright, so now this is a server territory. We should make a server instance as well. Var server. And let's go. Let's add everything server needs. Clients. Oh, I think we need an init function, which is going to accept a single instances of everything, and an allocator, of course, because we will be doing too much code writing all this array lists and initialization of array lists and stuff. Yeah, let's make it just an init function, which will make our lives a lot easier. So we will accept a single client, yeah, and a slice of text, I believe. Content, yeah, a slice of text, and we probably will want to duplicate it, but at the same time we do duplication in the text buffer. I will maybe reconsider this decision, because we generally want to be more explicit, and I believe more explicitness will be when we have everything in the init function, which does all the memory stuff, and we don't realize that in the init it calls another init, and another init actually duplicates something. Initial content, or initial text. Okay, let's go like so. A client. So how are we going to receive a client though? Oh, a client is not really a client, it is a pair of file descriptors. And since we have a type for it, maybe we should also make a type here. Client pipe fds. Yeah. So now we have a reason. Previously we didn't have a good reason to make it a separate type. Now we have it. All right. And we go like so. We just return server. Yeah, let's make a self. I don't have a particularly good reason to use self, but I like it as a general design decision. Self, and we will return self, of course, not void. Alley. Yeah, we need an allocator as well. Allocator. std mem allocator. Yeah, this word is kind of too big. I like alley. I saw it maybe during the presentation of the Riva file manager. It is a work also in Zig by iFreund or iFreund. I believe he is also a contributor to the Zig compiler or something like that. So very cool Riva compositor for Wayland. I will of course try it one day. For now I'm on Xorg, and the next time I switch to Wayland, I will use Riva. Definitely will try it. Okay, now we will need to initialize our first array list. Okay, toStep says hello. Yeah, hello, welcome to our little Zig stream. Var clients is std dot array list, and it will have client pipe fds, and we will also initialize it with our allocator, which we will call alley. Clients. Yeah, and we will also push our client to the newly initialized array list. Clients.append client. Okay, and other stuff. I believe buffers, text buffer has some initialization function. Let's check it quickly. Text buffer, yeah, it has init and content. We'll probably change it a bit later. Let's leave here to do change interface, to do duplication right in this function. So we have it up front, a more explicit approach, I believe. So here we say text buffer.init, we pass it an allocator. Yeah, also maybe allocator should be only in the server, and since everything that is contained in the server will one way or another have some link to go up to the server, it will make use of this allocator. I think this is also a good idea. Yeah. Allocator and content, we call it here initial text. And display window, display windows. Yeah, here we will also need to do some boilerplate for that with array lists and stuff. So toStep says, looks like you are working on separating into client server. Yeah, that is correct. We have already written kind of client stuff, and this is our server stuff. For now, we don't do anything too smart, and we just use where is it? Server. Yeah. Wait. It is a very good thing that. Okay, I think I have lost a bit. We did some pipe stuff because we did some encoding, but I completely lost where we did it. Oh, here, yeah, right. So we use we need to pass 3 arguments: the slice, the first line, and max line, and we use just a character pipe to separate them. So we're doing some really dumb communication, just like a proof of concept stuff. And now we are finishing up the initialization and this stuff. Text buffers, std array list, and we use pointers to text buffers. Yep. Oh, okay, so here we have a pointer, so we'll also need to actually allocate it, not just init. Okay, so it becomes more and more complicated. Hopefully we'll be able to do at least something. Okay, so we will need to initialize it with Ellie. Ellie has create, I think. I'm not very fluent with allocator stuff. fn create, so it creates just a single instance. It's what we need. Create type, and we get our pointer to the type. Yeah, okay, I think that is fine. So we have our array of text buffers. Now we will need a pointer to the memory. Text buffer ptr, yeah, for the pointer. And we say le.create, and we want to create a text buffer. Okay, so now this thing should be located at the memory address of this ptr, and we do it like so. Okay, and we go like so too. I believe this is the right approach, right? We do initialize our array list with init. Yeah. Then we create our space on the heap for the pointer to text buffer, and we assign some content to this pointer, so it's not garbage data. Yeah, looks fine. Okay. And two-step replies, Zik is more like C than C++ or Rust, which have more semantics. Yeah, I think I agree, but what do you mean by semantics, by the way? I'm interested, do you think that Rust and C++ have more semantics and it is good? I believe, I have a feeling like Zik has like a very narrow set of tools, but semantics are pretty expressive nevertheless. Just this kind of feeling. Some feelings, I previously coded some NIM stuff, and in NIM like operator overloading and macros, something like head blowing, and maybe it adds something, but at the same time Zik solves same problems with not operator overloaded, but at least macros. Zik's or maybe generics, like not macros. Macros may be next level stuff, but generics at least Zik solves like very trivially. I really like the approach that you can pass types as function arguments, like really cool. Okay, and we do same stuff for display window, I believe. Display window. Yeah. By the way, here you just saw like I did this cool thingy with like editing several places at once, and I hope we'll be able to implement it quite easily, because I'm not sure how to implement it yet. The reason is that the terminal, this black thingy, it has a notion of a cursor, as I understand. It is here, and I believe it has a notion of a single cursor. So multiple cursors, we will be alone here. Terminal is not going to help us here much. Okay. Okay, so this looks fine. At least I would like to believe so. We have our server, we create it, and everything should be hunky-dory. Okay, now we have server, and we say init, and we pass it what? Ali, client FDs, and initial text. Okay, we can do that. Alright, let's continue. We will use, we'll just create our server, and we will use server.init, ali. We will need to pass client FDs, or not client FDs, but server FDs, but we call them client. Do we have a better name here? Tag already? Yeah, right here, better name. I will have a lot of free time offline trying to fix all this naming stuff, because today is not the most lucky day in terms of naming. And we want to pass an array. Can we just do it like so? Is this going to work? We go with OS FD T, and we say we want to pass. So what is read, what is write? 0 is for read, so server reads and server writes. Okay, so it looks like we did something. And we want to also pass content, the file that we initially have read. Okay, we will comment that just for the reference. Now, after we have created the server, we would like to send text. And it does not accept any arguments, which is good with us. Server.send text. Alright, I think server is done. Now let's comment this stuff for a while. It is our waiting for key presses and reading them. We don't need it yet. For the client, we will need also an init function, I believe. Yeah, let's write an init function for the client. So server pipe FDs, we'll just write it like so. Ali, just for future, because I'm sure we will need an allocator. Maybe I am wrong and we will have to delete it. It is also fine. Here we go like this. Here we go like this. Maybe we should have just like a type file descriptor pair, yeah, for easier typing. Let's add another to do, better name like file, or maybe pipe pair, yeah, like so. So two-step says, I actually don't have much experience using C++ Rust move semantics, but generally Zig is very explicit and doesn't do things like make large copies behind your back. Oh, you're talking about this value semantics that when you use equals, it copies, and in other cases it passes like by pointer and stuff. Yeah, I think I understand. Yeah, I think Zig is more explicit, and I like this. For example, the print macro, as not macro, but print function, as I understand in Zig, it fmt, right? In Zig it is like without tests. Let's see how much code is it without tests. Yeah, like 1700 lines, right? For printing. Well, there are some tests. Okay, maybe 1000 lines for printing, but it's done without an allocator. You don't have to pass an allocator to this format function. It does everything at compile time, and I believe in C or any like C++ it allocates something. And in Rust, I believe they have like print exclamation mark, and it means that it is a macro. And from the stories around, I've heard that it is implemented. Print has a direct support in the compiler, and that is I agree that it is too much. If we can avoid that, we definitely should. And Zig can avoid that. That is beautiful. Okay, we were writing our init function, and we need a UI. And what does UI actually entail? Is it just a front end? Yeah, so we probably still want a front end. Thinking about this server client architecture, we will still use import like this keyword to import some stuff. So I believe my initial idea that we need a client server architecture to support different front ends is completely failed, I believe. It was such a silly idea. Yeah, who was it? Yeah, Veligo correctly said this idea that imports, we will use it anyway, so why do you even write a client server architecture? I'm so dumb. Sorry. Okay, Matuba says Zig cannot make copies behind your back because it has no move semantics in contrast to C++ Rust. So Zig doesn't even have move semantics. Well, that sounds. I think that sounds all right. I believe in Zig, move semantics is that you just pass an allocator everywhere where you have to pass an allocator, and it kind of serves the same purpose. That is my understanding, at least. Yeah, very interesting decisions in Zig. There are many languages, and Zig has some very interesting ideas that you cannot find in other languages. Okay, we were still writing our UI stuff, yeah, UI, and we say that we get self. Const self this. Oops, capital T. We can have an error. We'll use an explicit error further. Self, and let's just populate the fields. It should be pretty easy. Ellie is going to be Ellie, server pipe fds, server pipe fds, yeah, the dot, oops, insert mode dot, right, and UI. And accept is not going to accept any additional arguments besides the client, so we are Gucci here too. Syntax, yeah, let's go to here. We say that we want our client init, yeah, Ellie, a pair of fds like so, and a UI instance. And here we want to say not server but client. Oops, I didn't mean that. Server, client. And we say that we would like to listen for the server to receive what the server has for us. Try client dot, how do we accept, right? I think it was accept. Okay, so now we will try to compile it. Zik will tell us maybe 10 other things which we did wrong, but it's good. It's good. All right. Has no member called pipes. Well, we were wrong at the very beginning, I suppose. So maybe we can look at our proof of concept implementation. OS pipe. So we have an S, which shouldn't be here. Pipe, just pipe. All right, next. Array access of non-array type. Oh, okay, we forgot to use try in both cases. And integer value cannot be coerced to type. Okay. So here we should use try to, reasonable. Does not support field access. What about field access? Maybe the signature of this function is not correct. Server, send text. It can return an error. We say that. Okay. Oh, our init function can fail too. I see. So next one, 342. Attempt to dereference non-pointer type. Oh, okay, we didn't say try here. Sure, we should have. Expected type text buffer, found error text buffer. Yeah, our text buffer can fail too. It's init function. Expected error union type found 340. Okay, so what's wrong here? No, we shouldn't try this one. Why did I write try here? Yeah, I don't remember. Ah, here because of this error, right. Here should be try. Right, I just have put it in the wrong place. Right, more errors. 346. Oops. Ali initial text. Yeah, we should not create like this. It should accept different arguments. It should accept our text buffer. Right, let me take a look at our display window init function. Text buffer, just a pointer to the text buffer, right? We have it here, so we will just pass it. Yep. And the use of undeclared UI 18194. Yeah, here we also have a little problem here because we still use UI in the init call, and it probably means this is an information that the client has because we want to show the rows and calls. This rows and calls, it is a visible area of everything that where we can print our text. We should know the dimensions so that we, for example, if we open like a 100 megabyte file, so that we only send the needed amount of text. And we make some hints about which line the first line, which line starts, maximum line, and what is, and we do these calculations based on the available space in the terminal. So I suppose for now we can just pass these values in the init function, but we will have to change it later. Or can we even do so? Maybe in the ideal way, we will have to send from client a message to the server. So, hey, I was initialized. Here are my dimensions, and the server will just put them in the current display window. Yeah, and yeah, someone let me close my window. Someone's been very loud. Okay. Alright, so we wanted to pass some additional values. We will use for columns. We don't really care about columns right now. And for the rows, we'll pass rows, then columns. For the rows, let's pass 5. And for columns, 100, because we don't really care for now. So where is our display window? Yeah, it was somewhere below. Client server. I think I'm missing it. Yeah, here. So we want to add rows, which is U32, and calls, which is U32 U32 Alright. Rows is rows, and calls is calls. So, should be fine. Let's try. Okay, some more clients. No member named client. Yeah, should be S. No member named UI instruct display window. Yeah, that is correct. We can just delete that. And okay, some more errors. Use of undeclared identifier clients. Self clients, is this correct? Self clients, yeah. Self, and here, and yeah, enough. Does not support field access. Expected type found const 210. So we expected U8 and we passed const U8. And why do we expect U8? It is a function. It is a function from the standard library. Yeah, okay, maybe we can just write here var to make it not const. Or does this function return a const? It does return a const. Okay, maybe in the end we still have to create our writer. But okay, that is not a big problem. Text.writer, yeah. And we will use W, and for here we will not need a writer anymore because we have already created it. And for every append, we will say write all. And I believe it accepts a string or a byte too. Let's see. Writer, write all. It accepts, it accepts a slice. So let's just use here a string versions, not just 1 byte. And yeah, one more error for now. It says does not support client access. So is this try? We are failing somewhere in it. Let me see. Well, we have put here exclamation mark, but we don't really have any errors. Maybe we can just remove it and not do it here. Okay. 2 steps as use append, slice, or write byte. Yeah, I just want it to be as simple as possible, and write byte is a good I didn't remember it when I wrote it, but here it just doesn't matter. Like, we can write byte, we can do write all. We will as soon as we complete it, we will, the next step will be to obliterate it and rewrite it with proper JSON-RPC. So for now, we can just be okay with whatever we write. Okay, 300. Server pipe FDs. Yeah, so we cannot do that. It's a bit of shame. I thought we can kind of give aliases, because we pass here 2 params. Yeah, I think we will have to use either explicit names in the struct client itself, or we'll have to add these lines in every function. And I certainly do like adding it to the struct itself more. Okay, so we still need self here. Do we need self anywhere else? Text buffer. Do we have text buffer? Where is our text buffer? Oh, it's client. We don't even have text buffer. But here we have this text buffer. What's up with that? Why do we... Okay, we will need to read some code. What have we written? Text buffer max line number. Yeah, we don't need to reference the text buffer. Correct. Okay, so I really like Zeek for its errors. It will not let me make a mistake. And we have something wrong with our types, yeah? String, first line number, max line number. So we have self, string. Oh, what? Oh, I see. It expects here. It expects. Okay, let's do it in a silly way. Maybe we can just not do silly printing. No, we probably should keep the interface as good as possible, and if we have to convert these things to numbers, let's just do that. Parse int, I believe this is. And we say U32, right? SD FMT, I believe. FMT. Let me quickly check it. FMT, FN, parse int. Yeah, we pass a type buffer and radix. Okay, we pass a type, a buffer, and radix is 10. Sure. And here 10 to okay. Unused local constant. Okay, let's just comment that. Oh, it compiled, but it says something about there's no member called pipes. I think it's previous error. It's not what. Let's reset the terminal. Do it one more time. Okay, so we have something. We have some progress. Yeah. And Matuba says, dumb question. Why don't you set up Cocoon to spawn the right terminal and pipe into it for builds? You mean why don't we have why this is a terminal and not a Cocoon? Is this the question? Spawn the right terminal and pipe into it for builds. Or do you mean that we will have still a terminal and Cocoon will execute a process on the background and just insert some content in the terminal? I believe the second version is a little bit more complicated and it requires quite good API from the terminal itself. This is Kitty. I use Kitty and it has good support for it. But I doubt that it will be fun to implement it, because in Cocoon you mainly do with Bash scripts, and I'm not very fluent with Bash, and I don't intend to be fluent. Okay, this is somewhat bad, our input, because we initialize our new curses content like new curses. We don't use new curses, but if you use new curses, you understand it. And because of that, we have all the messed up spaces are all messed up, and these carets also a little bit messed up, but we have still lines. Let's work with that. So it says index out of bounds. I believe it has something to do with the split iterator. Is this right? Can we do some debug output? Maybe here, maybe one of these lines, right? We have a reference from here, first line number, and here first line number. Index out of bounds. I believe we fail to parse on this pipe character. I would like to print whatever we get from our buffer. Let's try to do that. Std debug print. And we want to print a string. Yep. And this one. We have read some bytes. Now we want to print them. Will we be able to see that? So let's look. Let's reset our terminal. And no, I don't think we can do that. So I still didn't figure out how to do debugging, printf debugging, my favorite type, but also LLDB debugging, like proper debugging. I don't know how to do that with initialization of our new curses. Probably we'll have to do like piping to a special file, like all the errors will forward to the file, so we can later just inspect the file to see everything we have printed in the debug. Matuba says the nice thing about NeoVim is that you have inbuilt panes plus terminal history, and you can capital F to the exact line of the error. Yeah, that is true. That is a bit more of, I think, like an extension, or maybe just a simple interface. Yeah, for example, I think it can be done with a simple interface and as a third-party example. Here in Cocoon, we have a grep command, and it prints in a very special format. Let's grep for like main. Right? It prints in this special format, and what it allows us to do is to press enter, and we will be on this line. So I suppose that we can do same stuff with errors, and it will do same deal. We will need just to add support to write errors in this way, some communication with the compiler. Yeah, and we will need to implement this in actually our editor, not in the Cocoon. And two-step says, do you need to dupe the strings returned by split it.next? That is a good question. Do we? So here we definitely do not, because we parse in an int and it's free, but here with slice. So let's us see if we pass here a slice. In the render we accept our slice, and what do we do with it? We split on it and we write it. So I believe no, because we don't really do anything too like specific. We just use same pointer, same slice, and we instead of going by our pipe operator, we do it by new lines. So it's a good question, yeah, but I guess we do not want to duplicate it. Okay, maybe we can find out. Can we do just std os exit, or we can comment some code? Yeah, let's go with commenting, because since the last, yeah, we want this stuff. How do I, like so? No. And like so, yeah. Since the recent compile update on the master, we cannot have unused variables, and it complicated things a bit in terms of we pass first line number 1 and max line number 5, for example. Yeah. It complicated a bit things with unused variables, because you always have to comment things and do a bit more work, but the idea that in the long term it will be more useful. Okay, so something happens. Yeah, I think what happens is that our client runs, our client runs, it accepts, it prints all the errors, but it finishes and it closes its Nico's content. So we will have to insert a while true loop, right? While true. And I bet compiler will say, oh, this is no return function, you cannot do that. Okay, 1. We have 1. It's a good start. At least compiler allows us to compile it, and now, because of the context, we have some black magic here. Because of that, I cannot press Ctrl+C to terminate it. So I will just close the terminal and open same stuff again. And Kisa, yep. So we probably still want this our loop. No, we do not want our loop, because okay, let's just close it. I'm okay with closing for now. Okay, so what can we do? Because it prints some garbage. I believe it prints some garbage because of our std debug function. So we already do something wrong in the std debug. Std debug, yeah. Here, where was it? Do we not print it? So we don't even have a print function. Okay, so current task is to figure out where from do we get this garbage content before switching to something else. Okay, so we were editing these lines. And TwoStep says the previous error seemed like you had an uninitialized array list, like its items field was zero-sized and trying to access first entry. Yes, I agree with that. Maybe it's a place where we should look. But also I'm a bit concerned that if we do it like so, we get a proper error. We cannot even continue. So this one is a symptom. Maybe we should look at the source. And the source is that we get a slice by splitting on the buffer, and we try to read everything. And we use this buff by thread. So to me it looks like here we either do something wrong here, or we here we read, and on the right side here we write some garbage. Where was it? Below? Yeah. Here this message is some garbage. I would really like to look at what this message actually is, but I don't yet know how to do this. I don't know how to debug things in this context. It is also another to-do entry, I think, and a very important one. How to debug. Message, display window, render. Render this. ZLS? No? Okay, we will find it ourselves. We want a display. Display window, render. So text writer, we initialized our array here. This is a message which we would like to send to the server. And we call this toOwnedSlice. I'm writing this function for the first time, but I saw it in the standard library. I guess it should work as expected, as I expected. This code looks fine to me. Yeah. Okay, down the line we have self UI render, which is a bit different. We should also disambiguate words for rendering to string and rendering on the terminal. Yeah, another to do better name thingy. Here it also doesn't make sense. We can remove it and put it here. We render to string. In Ruby on Rails, there is a method called render to string, which does same stuff as render, but it renders it to string. So I could go with that naming. It doesn't look too bad, but maybe we can make up something even better. Okay, let's try to output some stuff in our terminal. We will make it a bit smaller because these errors take up too much space. We reset it. Would TwoStep says, would std debug panic help with print debugging? Let's see. Let's actually see at what debug module has to offer. And you say debug panic. Format args. Okay, maybe we can try. I just hope that our compiler wouldn't be too smart and say, oh, here's unreachable code, you cannot use panic here. Okay, let's do it with that thing here. std debug.panic, like so. Buff 0 to bytes red. Let's go. Yeah, reach. I hate it. Okay, so we return void, so we can just comment everything below. Okay, what do we have? Panic index out of bounds. So do we panic on this exact line? Huh? Is this the line we panic? Because we let's go one, just one. Okay, we can just do it like so. Maybe the gods of the compiler will be merciful to me and it will compile. No. Okay, index out of bounds. So can we are investigators. Where is the error? Text buffer, self, text buffers, items, 0. Okay, it gives us a pretty nice clue. 366. 366. Self, text buffers, items, 0. Okay, so maybe we don't have any text buffers like here. Do we even append? Yeah, two-step, you were right from the beginning. It was this array list because I don't really see any append operation here. We do everything but the append operation. Yeah, like so. And same stuff for the windows. That append, window ptr. Yeah, like so. Yep. And what is our error now? Index out of bounds. 366, so maybe we are short somewhere still. We append the pointer, so we should have at least one. Clients, we append the client directly. That's true. Okay, let's go to 366. And here it is. I think we have some output from the past interaction, and we have to reset. By the way, this reset command, it does not only clear the screen. For example, if we have some garbage there, we can use a clear command to just clear the screen, but reset does a little bit more, because we have our terminal in the change state, and sometimes it does not execute the defer hook that restores the previous configuration. This reset is exactly does what it says. It restores the previous configuration, so we can have better output in the printing, not mixed with the previous errors. Okay, segmentation fault at address 0x0. Last line number, self first line number, then try display window render. Okay, it is referenced from here, and it says that last line number, it gets a segmentation fault. That is interesting. 207. So do we get a segmentation fault right here? That looks so strange. I usually get these kind of errors when I'm interacting with a C code, but in the Zig itself, it's probably because we interact with pipes, do some reading writing, and we get this C-style errors where you have to figure out on your own. But at least we have some stack trace. In C, we rarely get even that. That is hopeful. That makes me hopeful. Okay. We don't have a lot of info here. 370. Somewhere here. Maybe we should comment something. A slice to line. What does panic, by the way, do? Does panic cause a segmentation fault in any way? Or is it also connected that we change the state of the terminal, and when we panic in the change state of a terminal, it causes a segmentation fault? So many questions. Panic. Okay, can we just comment this panic and go with our old code? Reset. And okay, we commented this previously. Now we can uncomment it. Yeah, still same segmentation fault at address 00. Okay, so what do I do? Please, Zig, help me a little bit more. That is not enough information for me to fix the error. What do you mean by segmentation fault? At address 00. At address 0, I mean. LLDB time. Well, you go. Well, I will show you some LLDB magic, right? So we build, right? We build our stuff. Now we run LLDB, and we say zig out bin Kisa, and we say, yeah, we just say src main.zig. Is not a valid command. Yeah, run. And maybe before that we just put a little breakpoint at file main.zig at line 207. Okay, how do S. Yep, and we do run. Oh, okay, that is very good. That is, yeah, I like it. Previously, I didn't try to do it with our own implementation of this new cursors stuff. With original new cursors, I couldn't do that. So that is very encouraging, I would say, that I can use LLDB debugger here. Okay. Two-step asks, did you forget to append a display window somewhere? That can be a reason too. Yeah, right. I think you're thinking in the right direction. That if we fail at the very first line of the render and Zig gives us this strange hint that this is somewhere where this function fails, maybe we call our function on an initialized pointer. Yeah, I think this is a very good idea. Yeah, thank you. So we called it previously, what was it? It was 207 and oops, somewhere here. Display window. I don't know, maybe somewhere here. Client init, client accept. In the accept we say, no, we say display window in the server side, so it should be somewhere here. Text buffer, display window, 0. Yeah, I think that is the reason with the text buffer. Text buffer accepts const text buffer. It has this kind of silly array of display windows, and I guess it does not really do what it is supposed to do, because I don't really see it here. So yeah, that is yeah, to step, that is a very good guess that we have just a broken init function for the text buffer. I think it's our last monster to beat until we get our working proof of concept server-client communication. It's definitely a lot harder than just plain import stuff. Okay, but maybe we still should have done it because it is a memory management related thingy. So I think my connection is very troubling. Let me restart. So, okay, we had some internet connection problems, but anyway, I would like to wrap it up. For now, the stuff that is left is this init function, which is broken. We'll put a large to-do entry here, like a very large to-do. Because it is broken currently, it is, I think, the only block in stone left, which does not allow us to complete our client-server proof of concept interaction. But so far it looks good. So I will leave it for later. I will probably do it off screen, offline. But for everyone who is watching, see you next time. I believe I will do more work about conceptual review so that everyone can easily see and grasp the ideas and architecture about this code editor, and I hope I will discover something new for myself too. So thank you all for watching, and bye.